Okay, now we're going to start chapter 6, and chapter 6 is going to be about rational expressions and equations. Okay, and basically, if you remember from our sets of numbers, rational means can be written like a fraction. So a rational number is just another way to say a fraction. So a rational expression means we're going to have variables in our fractions. Now, I beg to differ with what they say right here. This is not true. Okay. Well, I guess since we're at an expression, okay, but when we get to an equation, so these are rational expressions because they're fractions, right? And they're expressions because we don't have an equal sign, but we have variables in them. Okay, so when we get to equations, I'll tell you what I was about to say. But I'll say, okay, that's a rational expression. It's an expression with a fraction in it. Okay, remember, okay, denominators can't be zero. We don't have to worry about that on ones like this where the denominator is just a numeral. But on ones like this, that's going to be important to us. We got to make sure that we're not ever saying the denominator equals 0. Okay, so one thing we can do with rational expressions is just evaluate them if we know the value of the variable. Just like we can do with any kind of an expression, if we're told the value of the variable, we just plug it in. So it says evaluate these when x is 3. That means everywhere there's an x, I'm going to replace it with a 3. Right? Everywhere there's an x, I'm going to replace it with a 3. Okay. Watch our bars too. Make them go completely over everything we need because that means something different if the bar doesn't completely cover it. It means it's not under there. So 3 plus 1 is 4 and 6 plus 1 is 7. Okay, so on this one, if I replace every x with a 3, I get 3 minus 3 over 2 times 3 plus 1, or 0 over 7, which is just 0. Okay, down here, replacing every x with a 3. We get 7 over 0. Can't have zeros in denominators, remember? So we're going to call this undefined. Undefined. There is no definition of how you can divide by 0. Okay, if you have trouble remembering that, maybe thinking of is 0 is on top and a number on bottom, that's right on, all right? That's all right on, you go. But if the number's on top and 0's on bottom, no, that's the one that we cannot have, right? Number on top, 0 on bottom. No. We're going to call it undefined. Okay, if you want to, I'm sure that's what they're going to call it in MyLabs Plus on the test. If you just say no solution, can't do it, something, right, to tell me, don't just leave that, don't do that. You got to say something to indicate to me you know you can't divide by 0. Okay, so one thing that you always do if you have a variable in the denominator, you have to check your answer, right? Because if you solve this and you say that your answer is x equals 3, we can't solve this, but if we had an equation, which we're going to have, and you say x equals 3, and you tried to plug it in, you'd get that situation we just looked at. So right now, one thing you're going to be asked is what values make this expression undefined? And all that means is set the denominator equals 0. Any places, any values that make the denominator equal to 0 cannot be part of our answer if it's an equation. And so we restrict those. We say, oh, it can't happen. Okay, so like this one, it says find any values of the variables that makes this undefined. All that means is make the denominator equal 0. And then solve that equation. if we add 5 to both sides. So x equals 5. So you got to say x cannot equal 5, right? Now be careful how it's worded. If it says find the value is 5, right? Or it might ask you to say, you know, x is not equal to 5. Okay, same thing. Find the values that make the expression undefined. So all I need to know are what values make that denominator 0. And this time there's going to be 2 values, right? How do you solve a quadratic equation? You make it equal 0, so we're good. And then you factor. Okay? 2 numbers that add to give 8. Multiply to give 8. Add to give 6. You got it. 4 and 2. Which means r plus 4 cannot equal 0. And r plus 2 cannot equal 0. So the values that make this undefined are -4 and -2, because that would make them 0. So be careful of what they want. Are they saying what values make it undefined? Then hey, if r is -4, it's undefined. Okay? Or you could say r cannot equal -4, r cannot equal -2. Okay, let's look at this one. Okay, this one takes some thought. Okay, this thing won't factor, right? It's 2 terms. That's not a perfect square, and even if it were, that's not a minus. So think about this. When you square a number, what kind of value do you get? Positive, negative, or 0? Okay. You might get 0 if it's 0. But it will never be negative, right? It will never be negative. Okay? So that means this is some positive number, or 0, plus 5. Hey, if I have a positive number here and I add 5 to it, I can never make it 0. I can't make this denominator 0. That's going to happen every time you have the sum with something squared, right? Because you'll have a positive number plus a little bit more. Okay, so there are no values that make this undefined. No values make it undefined. Again, depending on how they ask you the question, okay, you might say it's possible to have all real numbers for an answer there. Even if this is -2. -2 squared is 4 plus 5 is 9, right? I can't make it 0. That's kind of a tricky one. It's not tricky, you just got to think about it. Okay, so we're going to talk about simplifying these expressions, right? A rational expression is in lowest terms, just like a regular fraction, if there's not any common factors in the numerator and denominator other than 1. All right, so they start out just to remind us, what if we had a fraction? It's no longer a rational expression, that's just a rational number, a fraction. All right, I'm going to go back to basics because we're going to need it when we put the variables in there. Technically, what we do, remember, is we list all of the factors of that number, all of the prime factors of this number. And since 45 is 9 times 5, I could write that 9 as 3 times 3 times 5, right? 3 times 5, 9 times 5, and 9 is 3 times 3 times 5. So this is 9 times 5, 45. So if I wrote all of the prime factors out in the numerator and the denominator, then anything that's the same in the numerator and the denominator can divide out, right? We've been doing that with numbers since 4th grade, you think? Okay, so that shouldn't be anything new. And that's just the exact same thing we're going to do down here. Now remember, if everything divides out, it leaves a 1, not a 0, a 1. And on the bottom there's a 3. Because we can say everything is times 1, times 1, times 1, times 1 doesn't change anything. So if everything else divides out, there's still that 1 left. Now, same thing here. I could write that 6 as 2 times 3, and I could write p cubed as p times p times p, and then 2 times p, so that anything that's the same in the numerator and the denominator divides out. The only thing left in the numerator is 3 times p, and the only thing left in the denominator is 1. Now, if it's in the denominator, I don't have to write it. I do up here because 1/3 is not the same as 3, right? But 3p divided by 1 is 3p. Okay, so that's what we're doing. The exact same thing. Has to work the exact way as numbers. These variables just represent numbers. I just don't know which numbers they are. But it works the same way that numbers work. So let's think about this. Instead of having to go to all this trouble, couldn't we just say, well, we know how to work with numbers, I hope. We've known for a long time that 6 divided by 2 is 3. And then remember our rules for exponents? Hey, if you got 2 p's on the bottom and 3 on top, 2 of them get to cancel out, see? And it's going to leave 1 on top. All right. Okay, now I got to be careful. Plus signs, plus signs. Think about this. If I had, let's see, what are we going to say? 2 plus 3 over, let's make it 1 plus 3. 1 plus 3. This is the fraction. 2 plus 3 is 5. 1 plus 3 is 4. Right? It's 5/4. If I try to say, hey, let's cancel these 3's, then that makes it 2 over 5/4 is 1 and 1/4. It's not 2, right? It's not 2. If you have plus signs, I've already told us what I think about plus and minus signs. Be careful. You know, don't do it. Think of the cross. Don't do it. Okay, so I got to be careful about that. Instead, I want everything to be multiplied. We're talking factoring. So in the numerator, I can factor a 2 out, and that leaves y plus 1. In the denominator, I can factor a 3 out. Oh, I'm sorry, that's going to leave it 2y plus 1. And I can factor a 3 out, and that's going to leave a 2y plus 1. Now remember, these are factors. Okay? So as long as this 2y plus 1 is the exact same as what's on the bottom, that can divide out. Let's try it again. Difference of squares, so I just got to know how that factors. A plus b, a minus b. Okay, this one's a perfect square trinomial, right? These are both squared. It's just the formula exactly for it. It's 2 times their square roots. So a plus b, a plus b. Anything that's exactly the same in the numerator and the denominator can divide out. Now be careful, none of that will cancel, right? There's plus and minus signs between them. Don't do it. Okay. All right, right in lowest terms. That's what we've just been doing. It's the same thing, nothing different. Okay, I don't know why they make the pages look different. Okay, z squared minus 5, 5 minus z squared. If these factored, they would be, everything would be a square. This isn't a square, so it won't factor. All right, can't cancel across plus and minus signs, no. So you might be thinking, all right, it's simplified as far as it can go. In any other circumstance, it would be, but also I hope you're noticing that, man, those are kind of messing with me. Why are they so close to the same? Okay, we have something that are called opposites. Okay, now like 1 and negative 1 are opposites, right? Negative x and x are opposites. We call those opposites. Let's look at this. This is a plus z minus 5 and then a minus z plus 5. In order to be considered opposites when we have multiple terms, it's easy when you just have one term. If they're the opposite sign, then they're opposites of each other. But if you have multiple terms, every single term has to be opposite of the other. Because, think about this, I could, if I took, I'm going to take this one down there. I could take either one. I'm going to take this one down there. And I'm going to factor out a negative 1. If I take a negative 1 out of there, so I pull a negative 1 out to the front, that would mean all my signs inside the parenthesis are going to change, right? That would be negative 5 plus z squared. Okay? Now, I'm just going to turn this around because addition is commutative, right? 2 plus 3, 3 plus 2, same thing. So I can write it in any order as long as I realize the sign in front of the number is part of the number. So I've got a positive c squared minus 5. Okay, now look what I have. Look what I have done to that denominator. Hey, it is identical to that numerator now. It is identical to that numerator. If I had that numerator on top now, these would cancel. And look what's left. 1 over negative 1 or just negative 1. Okay? Same thing would happen with these. If you divided either one of them, you'd always be left with negative 1. Negative 1, right? So if you can determine that your expressions are opposites of each other, you can just cancel them and leave a negative 1. That's how they cancel. Instead of being exactly the same and canceling and leaving a 1, they're opposites, so when you cancel them, they leave a negative 1. Okay, so it's explaining that there, which is weird sometimes. It seems to me like you'd put the explanation first and then show an example. But here's some more examples. Okay, now I got to make sure they're actually opposites before that shortcut applies. Okay, so I'm just going to go across everyone. And what I notice is, hey, those have all the same numbers and letters, right? So plus 5 minus 5, so far so good. Minus y plus, oh, those are opposites. That's going to cancel and leave negative 1. Okay, one more time. Because let's factor a negative out of the top. That would be negative 5 plus y over y minus 5. But I can turn, these are just being added. I can write it in any order. So I can make that y minus 5 over y minus 5. And now these are exactly the same, but I'm left with this negative 1. Okay, so negative 1. Well, these aren't even the same value, so I don't even have an option for that to be an opposite, right? Just when everything is exactly the same, I check to see if, hey, maybe if they're not, okay, if they're not exactly the same, I check to see if maybe they're opposites. But none of this stuff is the same, right? So it's just regular factoring. That top one is the difference of squares. Let me change color just so. Separate it a little bit from the other mess. 5x plus 4, 5x minus 4. Okay. The bottom one, it's not a quadratic, so my only choice is see if there's a common factor. Oh, I can factor 3 out of each one. Okay, so that leaves 4 minus 5x. Okay, I'm looking to see if anything's the same on the top and the bottom, and I notice, oh, well, maybe none of them look like they're exactly the same. Let's see if they're opposites. Positive 5x, negative 5x. Positive 4, positive, those aren't opposites, right? positive 5x, negative 5x, negative 4 positive. These are opposites. Does that make sense? Everything has to be opposite, not just part of it. So that'll cancel and leave 5x plus 4 over 3. Okay, this is one where everything is kind of the same. They're both 9s and k's, in other words, but not exactly. So, are they opposites? What do you think? Are those opposites? Yeah, I got my k's are opposite, but my 9s are not. So, if they're not exactly the same and they're not opposites, you're done. It won't simplify. Right? Got to be exactly the same to divide out. Or if they're opposites, they'll divide out and leave a negative 1. All right. Let me know how it goes.